Hi guys. So without wasting much time today, we just want to look at sequences and series. So just to refresh your memories, the sequence or the patterns may include the linear sequence with a common difference, or the quadratic sequence with with a common second difference. So the types of sequences, it can either be arithmetic progression or geometric progression. The arithmetic progression is normally identified by a common difference, and the geometric progression is normally identified by a common ratio. So in AP there is a common difference, and in GP there is a common ratio. So it's very important to identify any sequence as either a GP or an AP. Normally, if the question is silent about it, you have to figure out first on your own whether it is AP or it is a GP. I think that's the very first step when you do a calculation for sequences, and series. So you have to bear in mind how to do that. So you will be able to do that. You'll be able to do that. So now quickly, just for interest sake, let's see how we can differentiate, or probably how we can at least identify the AP and the GP. So we're saying AP, there is a common difference. For example, I'm gonna write here. I hope it's going to be clear to you guys. For example, I don't know how to do this, but I'm sure it's going to be clear and you'll be able to see what I'm writing here. So for example, a sequence 1, 4, 7, maybe and a 10 there. 1, 4, 7 and 10, that's a sequence, and it continues like that. So from this sequence, it is clear. Okay, you can easily observe that there is a pattern. There is a pattern that these numbers follow from one to the other. So for example, from 1 to 4, you see there's a difference of 3. From 4 to 7, there's a difference of 3. From 7 to 10, there is a difference of 3 again. So that's an AP, because we identified there is a common difference from one number on the sequence to the other. There is a common difference of 3. 4 minus 1 is 3. 7 minus 4 it's a 3. 10 minus so this is we can say that this is a first term, which is T1, and 4 is the second term, which is T2, and 7 is the third term, which is T3, and 7 is the third term, T3, and 10 is the fourth term, T4. So there's a term 1, term 2, term 3, and term 4. So it is very important to understand this simple process. So to get the common difference, you just say the number next minus the number the number in front minus the number behind. So to get the common difference, it is equals to, we can say T2, which is second term, minus T1. It should be the same across, like if you go to T3 minus is equals to 23 minus T2 is equals to T4 minus T3. You see there that in all these situations the difference is a 3. So we say the common difference is equals to 3, which is normally referred to as the D. The common difference is normally referred to as the D. You will see that you work with a D in all instances where you do the calculation for the arithmetic progression. So this is just a hint on the arithmetic progression. So I wouldn't want to talk about GP at this stage, just to avoid any kind of confusion. But so that you'll be able to differentiate, I'm going to talk about it quickly. So a GP, as we've said, is identified by a common ratio. So this was an AP that we're talking about, and talking about the geometric progression, which is a GP there. So talking about the geometric progression, it is normally identified, or it is identified by a ratio. For example, you have 5, you have 10, you have a 20. So if you see quickly there, if you subtract the 10 minus 5, it's a 5, 20 minus 10. So you see arithmetic progression is off already because there's no common difference. But now, since you cannot, arithmetic progression cannot do, then you can quickly think of the GP. GP is just to say the number in front, 10 over 5 is equals to 20 over 10. So in front divided by this, in front divided by this, front divided by this. So you see this, there's a 2 is equal to 2 there. So it's like that's a T1, a T2, and a T3. So to find the common ratio, which is normally referred to as R. The common ratio is normally referred to as R. So it's like T2 over T1 is equals to T3 over T2. That's how you find the common ratio. So this is just a way for you to understand the difference between the AP and the GP. But today in this lesson, we're just going to talk about the AP, the arithmetic progression, quickly. And in the next lesson, you'll find the tutorial on GP. So talking about the AP, talking about the arithmetic progression, we've said it's identified by the common difference. So sometimes the question doesn't really come to say, can you identify this? If it's a AP or a GP, of course you have to know that. But now the most important thing is for you to understand the sum and how to find the number of terms. So normally the nth term, which is normally referred to as Tn, is equals to a plus n minus 1 d. This is the formula for finding the nth term. The nth term. So the nth term here, it can be either the first term, it can either be the second term, it can either be the third term, the fifth term. So you find it T n just referring to the number, to the terms. So for example, you want to find the first term. The first term, we can refer it as T1. Term 1 is equals to a plus 1 minus 1 d, because n is equals to 1, since we want term 1, first term. So T1, the first term, is always equal to a. The first term is always equal to a. So in an AP or GP, the first term a is referred is the a. The first term is the a. So going to the second term, which is normally referred to as T2, because you see our formula is in terms of Tn. So T2 is it's the second term. It's Na, which is the first term, plus n is 2, because we are talking about the second term. So it's 2 minus 1, like on the formula, the n always minus 1 d. So T2 is equals to a plus d, because it's 1d, which is just the same as. So if you follow the pattern, that means you can easily say T3 is equals to a plus 2d. T4 is equals to a plus 3d. T5 is equals to a plus 4d. So you continue like that. So this is the first rule, what you will have to understand about the nth term. It is very critical when it comes to arithmetic progression. Then in arithmetic progression, we also have what we call the sum. The examiners also like this the part on the on finding the sum to arithmetic progression. So it's something that you should always you have the formulas in mind. You don't have to wait for the set of formulas. As you practice, you will always catch the formula. In mathematics, pen to paper practice is always very important. So the sum, we should know the sum to the AP. The sum of AP is the two formulas that you can use. Two formulas. There are two formulas. The first one is Sn, referring to the sum of the n terms, is equals to n over 2a plus n minus 1 d. So that's the first formula that you can all use. Or Sn is equals to n over 2a plus l. So A always refers to the first term. A always refers to the first term. N always refers to the number of terms. Then D, common difference, as we have highlighted just now, the common difference. And you also find out there is sometimes an L. L refers to the last term. So the second formula there, n over 2a plus L, you only use it when you have the information with the number of terms, the a, the first term, and also when you given, or when you can calculate the last term, then you can simply use that formula. The first term, you can use it generally, that is what is used, n over 2a plus n minus 1d. So depending with the information, but sometimes if the information cannot give you a d, so it's impossible to use the first formula. But if the information gives you an a and an l, the first term and the last term, then you quickly have to realize that you're using formula 2. So depending on the question given, then you can easily use either of the two formulas. So that's about it. I think in the next lesson I'll be posting some more questions on arithmetic progression. I'm sure you have find this lesson helpful. Tune in for the next lesson. Thank you so much. Remember to subscribe.